This conference will now be recorded.
Yeah, a list is a collection of objects. Okay, list is a collection of objects, and list is backed by array. It means the list backend is we will be having array. Okay, when you have an array in the backend, as we clearly know that what is array? Array is a linear list of elements which has index or list of, right? Here also list can have a collection of different type of object, and it will have an index. Indexing means what? Which position the data has been inserted, correct? Which position the data has been inserted. So if you take an example of uh, the list yesterday we have seen it, whatever the element you have inserted first, it will go to the 0th position. Whatever the element you have inserted next, it will go to the second position. I mean first position, index 1. Third element will go to index 2. It means that it maintaining the index, and while it is maintaining, because it has an index, the next one is it has a order, insertion order. The most important thing, the insertion order. It has the index, and also it has the insertion order. Insertion order, whatever the order you are inserting, the same order will be there. Whatever the order you are inserting, the same order will be there. And it allows the duplicate. And another important thing is it allows the duplicate. When it allows the duplicate, it means it's a collection of, or a sequence of, it can have a duplicates, it can have a non-duplicate, unique, and everything. And it allows the null values. It allows the null values. The most important feature of the list is allowing the duplicate and maintaining the index and order, insertion order. Is this clear? Is this clear?
Yeah, Ravi.
Okay, so in Scala, right? In Scala, by default, the collections whatever you use, they are immutable. They are immutable, but Scala provides a mutable also. The Scala provides mutable also. To get the mutable collection, we have to access scala.collection.mutable package. Scala.collection.mutable package. Okay, let me search. Is there any collections here? Let us see the document. This is immutable. This is immutable. Similarly, scala.collection.mutable will write. Okay, let me check for any other else. They're all immutable. They're all immutable. This is actually collection. This package contains the collection of the Scala traits and examples. One second, let me do one thing. Collection. This is mutable collection. Look at here. This is mutable collection. Okay, array buffer. Array buffer. This is a mutable collection. Okay, let's talk about the collection hierarchy, which I was talking yesterday. Okay, the hierarchy will be like this. I was talking last session. I think I have drawn somewhere. Okay, I'm just checking them whether they are. Okay, if it is not there, I'll draw again. Or else let me show the Google instead of I draw. It may take time. Let me show. some images. Sorry. Yeah, this is very high level hierarchy. Okay, traversable is a trait. Trait. You guys know what is a trait now. Iterable is another trait. In this, you have a sequence, non-sequence. There is no sequence. Here, sequence. Sequence means you will be having order. Sequence order will be there. Whatever the order you will insert, the same order will be there. That's called sequence. And you will be having set, where you will not be having a sequence. You will not be having a sequence for the set. And the next one is map. We'll discuss about these two in the after completing this. Let's talk about the sequence. Let's talk about the sequence. In the sequence, you have a linear sequence, indexed sequence. Linear sequence, indexed sequence. So in this linear sequence, there are some classes which comes under picture. Those classes are vector, string. String is a collection of string also a collection of elements only, no? Uh, Sorry, in this indexed sequence they come. Vector, string, any range, if you specify any range, they comes it. When it comes to the linear sequence, under the linear sequence, list, uh, uh, what I can say, like queue, stack. We'll talk about them one by one. Okay, what is the what is that? What is the uh, queue? What is a stack? But we may not be using extensively, but I'll explain you. Stream. There is something called stream. Java 8 it will come. List what we have discussed already. Okay, let's see one by one. Okay, let's try to understand what is the traversable, the top level or parent of all the collections. Parent of all the collections. It is actually, look at here, they have highlighted here also. Traversable is the top of collection hierarchy. It is a top level, it's a top level trait. It's a top level trait. Trait is nothing but interface, right? We discussed. It's like an interface. So this top level trait contains some useful methods. I will tell like head is empty. Um, what I can say last. There are some useful methods will be there in this. Useful for everyone can make use. What is the max? What is the min? What is the size? These are uh, reusable components, no, reusable methods. See, you take any collection, like you take a set or a list or some anything, they will be having a head, they are traversable, they will be having a last, they will be having a max element, they will be having a min element, they will be having a size, right? They will be, you can do the sum. So these are all contains the reusable methods. These reusable methods will be given by this trait. What is a trait? Trait is an abstraction, right? We discussed earlier. It contains abstract. So these are abstract methods. These are abstract methods. One second. హలో నేను సెషన్ అవగానే పంపిస్తాను మీకు మీకు సెషన్ అవగానే పంపిస్తాను. Okay, so these are abstract methods. When I say abstract methods, those are reusable components at low level. So people may ask what is the use of the abstract class, or what is the use of the trait, right? So you guys remember we discussed earlier, they will be used for the top level classes, and we will declare their abstract methods. So whoever the chained classes, they will make use of them, they will override them, like I have given an example of the bank. So you have ICICI Bank, HDFC Bank, S Bank, Citibank, right? So there will be a common methods. There will be a common methods. Those common methods will make it as abstract in the top level. So when it comes to child level, they will override them. That is the use of the trait and abstract. Try to remember, guys, the reusable components. When you don't know the functionality, so those functionalities will be declared in the top level, like a trait or abstract. Trait or abstract. So as I said, in this traversable, you have some set of methods. If anyone want to make a note of it: head, max, min, last, is empty, size, sum. These kind of methods will be available in the traversable, because these methods can be make use here, 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 anywhere in the down level, anywhere in the down level. So that is the reason this kind of requirement, what we will do, we will declare as abstract or sequence in the real time. Also, when you are designing your class or when you are designing your program, if any methods will be reusable or override in the down level, I mean subclasses, we will go with a interface or abstract. So here it will be trait or abstract classes. Is this clear to everyone? I think actually the trait and abstract also covered in more detail here. Is this clear to everyone? Is this clear or not? So when you have a low level classes is going to make use of some set of methods, those methods we will declare in the top level classes, which are abstract and trait. Simple. If anyone asks what is the use of the trait, so you can say this. So let's have an hierarchy. If I have any low level methods, if I have any low level classes, so which are going to have a common functionalities across the low level classes, I will declare these functionalities in high level in the form of trait. So when in the trait I'll declare the common methods, those methods can be overridden in the child classes. For that kind of scenarios, we will go with the trait and a trouble. Why I should go with the trait and a trouble? Because you will be having a set. Those set, you know that those are going to use in the down or low level, so they will override them. This is very common to everyone. So let's take an example of the bank. RBI is there. Rate of interest, it will give the rate of interest is the one function. So all the banks will have a rate of interest. It's a common. So now the bank, I can make it as abstract or trait. The rate of interest, I can make it as a abstract method. Get rate of interest or something like that. Okay. Next, immediately iterable. Traversable we have seen. Iterable. Iterable means very simple, guys, where you can traverse through the element. Okay. It is mainly used to iterate through your collection. Iterate through your collection. Okay. Is this clear? This is actually useful for iterate through your collection. Okay. Let's talk about this. Okay. Sequence. Let's talk about the sequence. Here, sequence also trait. So that's what we need to declare, guys. When you have a top level and when you have a child levels, we'll declare them as a traits. This is a trait, traversable is trait, iterable is trait, sequence also a trait. Sequence also a trait because the child classes are there. Linear sequence and indexed sequence. In this again, child classes are there. Okay. Sequence. What is a sequence? What is a sequence? Look at here. Okay, here also declared. Look at the iterable. Look at the iterable. Contains abstract iterator. Iterating means traversing through. Iterator method that all subcollections must define. Iterable also implements the abstract for each method from traversable using iterator. But as I mentioned earlier, a lot of subcollections override this implementation to optimize. So that's what, if you see, this is hierarchy, traversable, and it has a child as a iterable. This iterable actually help us to traverse through the collection one by one, first element, second element, third element, to traverse through each and every element. How you are able to traverse through your collection? With the help of the iterable. What iterable does? Iterable has for each, look at here, this is actually came from the traversable. For each abstract method, for each abstract method, look at here, traversable is a top level collection hierarchy. This defines a lot of great options in the Scala collection offers. Some traversable contains for each, but it's not only the method. I think it's, I don't know how it has been defined. For each is not only the method, it has other methods also, min, max, and all other stuff also there. Okay, so this is not only the method, the collection, or in traversable, sorry, iterable, traversable. It's not only the method; it will be having a lot of other methods also. Maybe I don't know whether this blog is wrong or not. I don't know, but it has a lot of methods. We can check the API also. We can check the API. Okay, let me see whether I am wrong or this blog is wrong. We'll just Scala API. Try to look for the Scala API. So Scala API actually helps you to clear a lot of doubts. Maybe version to version also they vary. So let me see that. I'm going to collection. Okay, this collection. I'm interested on the traversable. I'm interested on the traversable. It will be in the T. Traversable. Let me click on this. Traversable. Trait traversable. Extends a traversable like. Traversable. Okay. It has this one abstract method. Let me see other members. Yeah, these are other members. Okay. Collection from the head and all. Where this head and all comes. Head. These are the methods I was talking about. Head and is empty, last, is traversable, max, min. Okay, if that is the case, I can do one thing. 1 second. Let me see the source code of this. Sequence. Traversable. look at here, is empty, size, these are there. One second, let me go down and see. These are all the methods. Yeah, these are all the methods that have been overridden. Okay, but it is not showing why, I don't know. Look at here, these are all the methods for each. Is empty, size, head, tail, lost, take, drop. These are all the methods. Okay. Okay. Anyway, so you guys understand, right? So what I'm trying to show here is your one second, the value members. This is for the traversing. One second, guys. Sorry, man. Sorry. Yeah, sorry for disturbance. So your traversal will have the for each, and also these are the set of other methods also will be there. Okay. So similarly, when it comes to the iterable, it contains the iterator, and also it has some set of methods. Let's see that also. We can also see them. Iterable. This is the API document, guys. So the API document actually clarifies a lot of things. So even if you're reading from books or blogs, so if you want to cross verify, you can open this your documentation. You can check. Let's say I got a doubt in the iterable, right? So I'll go to the I'll click on the iterable. Okay, then I'll see what are the methods are supported by this. It is actually iterator which traversing through to it will help to traverse. Okay, then these are the methods are available. Oh, these are the common methods. Okay, so common methods are coming from traversable. Yeah, these are coming from traversable because it's a child of the traversable. Iterable is the child, traversable is the parent. Okay, next sequence. So as I said in the hierarchy above, sequence is a child of the iterable. Sequence is the child of iterable, right? Iterable is child of traversable. So what is a sequence and what is the special in sequence? How it is different than others? So sequence actually different kind of data structure where it represents the sequence of elements. It represents the sequence of elements and it gives the guarantee of the immutability. It gives the guarantee of immutability, and the advantage of the sequence is you have index. The list I told you, right? List got that feature from the sequence only. List is a child. From where the list got that indexing and allowing the duplicate and all, it comes from the sequence. Am I audible to everyone?
Yes.
Am I audible? Yeah. Okay. If I'm not audible or if I'm not clear, please ask me. I'll repeat it. I'll try to make you. Actually, I'm trying elaborating more the hierarchy. If you guys get any doubt, please ask me. I'll explain more in detail.
Sir, one question.
Programming part we can easily understand how to write a sequence, how to write a list, how to write a set, and all. It can be easy. But in interviewer, he will ask what is the use of it, what is it. So they will ask what is it, how it will work. So to understand, it's a trait. It got the functionality from the sequence and all. Yeah, go ahead with your doubt.
In this hierarchy, where list comes? List is also one of the collection.
List is a child of linear sequence.
Okay.
They have given very high level. They didn't give in detail. They didn't give in any detail. Okay, let me. If you want the complete diagram, let me check this. Hmm. This is the Scala documentation, directly Scala documentation. Docs.scala. Okay, you can see. Uh, Please keep yourself mute if you're not talking. Traversable, iterable, sequence, set, map. Okay. In this sequence, you have a two childs. Sequence has a two childs. Index sequence, linear sequence. Set has one child, sorted set and bit set. We'll talk about other sets also. Map, sorted map. In this, in detail again, look at here. It's the only set, it's the only map in detail. All collections, okay. Look at here. Your sequence, indexed sequence, linear sequence, right? Your list comes here, linear sequence. Your list comes in a linear sequence. And what are the string, a range, numeric range, vector, these are all comes from the indexed sequence. Okay, from the linear sequence, we get the list, stack, stream, queue. I was talking about these things. Okay, map and all we'll talk later. There's a different data structure. Key value pair data structure, that is hash map, list map, tree map. Tree map is a sorted order. Coming to the set, right? Set is meant for the uniqueness. We'll talk about them. We'll talk in detail. I don't want to make you confused. We'll talk in detail. Hash set, list set, tree set. It's a sorting order. It's a sorting tree set. Whenever you see, wherever you see tree, it means it is a sorting order. Ascending, descending, we'll talk. No, that's a sorting order, not the insertion order. Okay, set and map will not follow the order. Set and map will not have an index. Set and map will not be having the insertion order. Try to remember this point. Set and map will not be having insertion order, will not be having indexing. We'll talk in detail about those things. Only the sequence guy can have the only sequence will have the order and indexing. Why the sequence? The name itself is saying no, sequence order, sequence. Is it clear your doubt?
Yes.
Okay, so yeah, I think this is the best document that I can help you to. I can explain in this. Look at all the classes are defined here. All the classes are defined here. Okay, this is sequence represent SCQ. We'll call it as a SCQ. It's also a trait. Okay, and also the color codings. I'll tell you the color codings. All blue color. They will mention here itself somewhere here. The blue colors are trait. The blue colors are trait, and these black are classes. Okay, this dotted line is implicit conversion. The thick line is default implementation implemented by. Okay, so if you want in more detail, I can tell you which one is what I can say trait and which one is abstract class also. So in the classes also we'll be having a different classes, right? Abstract class and concrete class. Okay, look at here. Mm, all these traversable, iterable, set. Let me go top. These are all traits. These are all traits. Okay, these are all traits. These are all traits. Okay, when it comes to this black color, when it comes to this black color, these are all abstract classes. And these classes, whatever we use our own, you can also write your own class. You can write your own child by extending the list. You can write your own child by extending the traversable. So when you write them, those are your own concrete classes. Those are your own concrete classes. Clear? Okay. So we're talking about this sequence guy. We're talking about this I can say leftmost or rightmost or leftmost we're talking about. So this guy actually help us to get sequential order, help us to get index, help us to get insertion order, and he will allow the duplicates. This guy got from these things from all this list and all the child classes got these functionalities from the sequence, because these orders are there in the top level parent. Okay, list also child, right? So what are the parent behaviors will there? Those behaviors will come to child. Is this clear? Let me show you a simple example. Let me show you some simple example for the sequence. Okay, let me do one thing. I'll just write on simple sequence example. Parent, how we can do the parent, then we can see the child's one. Okay. Okay, let's create a sequence of numbers like how we created a, array of list of elements, right? Let's create a similarly where seq1, okay, sequence 1 equal to seq is a capital letter you need to do. I think we need to do the import. If yeah, I'll show you that we need to do the import, otherwise it will not allow. Oh, taken. I think we did import it sometime. Look at here, it's given you a list of elements. It's given you a list of elements. Okay, if I want to print this element, so sequence is from iterable, right? Iterable is from traversable, right? So traversable we have a for each. You remember we have seen this. Traversable has for each, right? Traversable has a for each. Traversable has a for each. It means I can make use of for each. That's the meaning of it, right? I can make use of for each. Let me make use of the for each. Sequence 1, my variable, actually it is an object. I should not call it as a variable. It's an object. Dot for each, for each, for each. I want to print element. I want to print element. I'll just do print ln. I'll just do a print ln. It will print like this. It will print like this. It will print like this. Or if you want to, I don't know why it is going leftmost. I'll just adjust the settings. Okay. Or if you want, you can do other functionality also. You can write it in a different way. Here, the same like element lambda. You can take this is what we can do, print element. We can just do print element. Print. We'll print next to next. It is a one by one. It is printed. We'll print in the next to next element. Take plus. Let's say space. Space is enough. 1, 3, 2, 5, 7, 10. Okay, so for each came from traversable. Okay, and I also told you I can it has indexing, right? I told you it has indexing. Let's try with index. Println. I want to 0, 1, 2, 3. Third position. I want to third position. I'll do one thing. I don't know why it is going leftmost. I'll use some space. 3. Yeah, sorry. I want sequence of 3, right? Sorry, sequence of 3. Sorry. SEQ1 of 3. Third position. I got the third position. Okay. So let's see what are the methods are supported by the sequence. What are the methods are supported with sequence? Guys, this is important. Directly learning list and set is quite easy to make you understand. That's the reason yesterday I just directly started to get you familiarity with the collection, like how this list will look, how the array will look, how you can access those things. But in the back, if you start explaining these things very first time, it will totally make you confused. What is a collection, how the traversable, how the iterable and all. That's the reason I shown you the how we can make use the list. Now if I start explaining, okay, you are able to correlate. So let's see what are the elements supported, what are the methods are supported in this. If you days execute one your object dot, and if you press tab twice, it'll show the tab, it will show the list of methods it will be supported. So it has a reverse, right? Let's try the reverse. Println reverse of this element. It's printed in the reverse order. It printed in the reverse order. It printed in the reverse order. We can also check. Look at here, contains. You can also check contains. Contains means what? What it does contains? Does it element is there or not? Does this element is there or not? Let me check. Is 10 is there in this list or not? Okay, I want to check is 10 is there or not. Println. Let me take something. Yeah, println seq1 in this dot contains 10. Element 10 is it element 10 contains in the list? What it will print? What it will print? Will it print a value or it will print
Boolean
boolean?
value.
Oh, yeah.
Yes, it'll print a boolean. Suppose if you want to do the if condition, if the sequence contains this element, do this operation. If the sequence does not contain, do this operation. So such kind of options you want to play, you can do. You can also check is empty. You can also check is empty. You can also check is empty. It's not empty. False means it's not empty. False means it's not empty. You can also check the head. Okay, what it will print when you call head? It will print the first element, number 1. Above 1 is the reverse order. Don't get confused with that. Above 1 is the reverse order. Okay, if I print a tail, I want someone to tell what it will print a tail. When I say tail,
Last element.
is it last element or apart from first element everything?
Okay.
Tail means don't get confused. So
Apart
normally we'll get confused like this.
last.
Yes. tail means we'll normally get confused with this. Tail means we'll always get confused, like it'll print only the last element, because we'll call always tail is the last, right? No, apart from the head, apart from the first element, everything is tail, because here there is no head, body, tail. There are no three parts, only two parts, head and tail. So apart from head, everything is tail. So if I say last, then you'll get only last element. If I say thing, it will say last, only one element. Okay, so are you guys able to follow?
Yes, Ravi.
Yes.
Okay, so this is about a sequence. It means you understand now, okay, sequence is also one top level class. It also can be useful to create a collection of objects. We can actually use that, correct? But sequence actually, as we discussed, is it's a trait. It's a trait. Sequence actually, it's a trait. So this trait has to be implemented by some classes. Those classes only linear and indexed. Linear sequence and index sequence. Linear sequence and index sequence. If you go here, you see this diagram. There is this mutable. Yeah, this one. The sequence is so the functionality, indexing, insertion order, allowing the duplicates, um, all these features came from sequence. Don't forget the sequence. Sequence is the top level class. Okay, let me write an example because I have not written an example here. Let me write an example here because I used to explain in that way, and directly I used to show the list and all these things, because list and all, we normally in the real time we will be using a list, set, map, these things only. But actually how they come, who is the parent of them, so those things will not concentrate more sometimes. Sometimes we'll concentrate, sometimes we'll not concentrate. So when you don't concentrate, so how this list working in the background will not be knowing, because the list got these functionalities from the parent. The parent is the this guy, parent is a sequence. Okay, let's keep object. Okay, sequence demo. Let's say main method. So we can create a val sequence equal to sequence of this guy, sequence of, we can give like some numbers, 1 3 2 1. It allows duplicates, 1 3 1 2 7 10 11 15. We can give, so whatever the order you insert, it will give the same order only. Whatever the order you insert, it will give the same order only. So there won't be any change in the order because it maintains the order. Okay, I want to index. Suppose I want to get the specific position. Let's say println. I want to get the specific position. Then seq1 of, let's say 0. Start with the 0 0 1 2 3 4 5. Fifth position. I want to get the fifth position. So you'll get the indexing. Value in fifth position. Value in fifth position. Okay. Index I shown you, right? Just print everything. values in sequence. I'll just print this to show you the order. To show you the order. Insertion order. Iterate through. Iteration. How will you iterate? What happened this one? seq1 dot for each. Okay, you can just write a println here. You can just write a println here, not the println here. Okay, or you can write like this also. seq1 dot for each. You can take element println of, not println, I want to print one by one, next to next. Element space, this one, some space like this. This is traversing. This is traversing. You got the position, index, you got the insertion order, the traversing, and also you can check the head and all the stuff also. You can check the head. Let me do one thing. Common methods in sequence, used in sequence. Let's say println. I'll do first one is reverse. Okay, I'll keep it here only. Reverse insertion order. I want very much specific. Insertion order, reverse insertion order. Whenever we say order, we always think like ascending or descending order, right? So I want to very much specific reverse. Okay, next I want to print head of the element, head of the sequence. I want to do tail of the sequence. I want to do last element, head element, tail element, this is last element. Okay, let's say contains, search for an element in the sequence. Search an element in the sequence. Say contains 10 is there, we'll go with the 10. Okay, what else you do? Is empty. Is empty. Check, is this empty? Check the sequence is empty or not. Check the sequence is empty or not. Okay, what else we can check? Head, tail, last. Okay, let's try with the min max also, guys. Okay, we discussed already min and max. Let's try this one. You can see here whether it's available or not. You can see here in the list. Max, min, max by, min by. I'll tell you what is a MK string. Okay, and also there are other important methods. Map, filter. Okay, there are different filter, flat map, flatten. Okay, flatten we discussed in the last session, but anyway, I'll show you once again. Fold, fold left, fold right. These are all important methods. These methods we'll be using in Spark also. That's the reason I'm saying it's important. Okay, so these methods we will use in the Spark also. I will explain those a little later. Okay, not now. Partition. Okay, we will see these things how to make use of them. Let's do one thing. What is this? Okay, println seq1 dot min. What is the minimum element in this? Because I don't know why my screen. One. Let's do max also. Maximum element is 10. Let's print the sequence. You can see that what is the maximum element. Okay. You can also see min, max. So whatever the methods I discussed earlier as part of that, you can also see all of them. Okay. Max element in the sequence. Max. Yes, Ankit. Okay. Okay. Mm-hmm. Okay. I'm in session. I'll call you in few minutes. Few minutes. Give me a few minutes. I'll call you back. Okay. So these are the set of methods, guys, which you can make use. Okay. Let me do this one. I'll just comment it. These are the some sample methods no, which you can make use. These are just sample. There are a lot of other methods although also there in the sequence. As I said, like they are all from the collection, part of the collection. So these methods like a fold, fold left, a fold right, filter, uh, filter, map, a flat map, a flatten. These are all methods, whatever you have seen here, those all methods can be used here. Okay, so from here only, your child classes, from here only, from parent only, your child classes got those functionalities. These child classes, your has this list, either is list or a map or whatever these things, they all got these functionalities from the parent. They all got these functionalities from the parent. Okay. Any questions? If anyone want to go read a kind of book, I recommend read Scala cookbook. It's really, really good. I'll try to upload the Scala cookbook also here. If you want to read a book, use the Scala cookbook. Alvin Alexander, the author is Alvin Alexander. It's a really, really nice book. If you want to read a documentation, go with the Scala documentation directly. So it actually gives you the most important things. Okay. Any questions, guys? Any questions? So we are not going to discuss all these collections. Is really not important for us. Okay. We will be talking about in this sequence. We already seen string, so I don't think we need range. Also, we have seen creating a range. Okay, vector and all is not really important. The thing we'll be more focusing on this sequence list, because we'll frequently using the list. But I'll high level tell you what is a stack and queue. These are the two different data structures. A queue is nothing but first in first out. Whoever enters into the queue first, you can access only the first that element. First in FIFO, it's a FIFO model we'll call FIFO, first in first out. Stack is last in first out, like your stack. An example, towers of Hanai tower or your CD. Earlier we will be used to have a box, so we used to keep all CDs in that box. So whichever you insert last, you'll pick it that last, right? First, you'll pick that first. So last in first out. These are the two different data models. Okay, stack and queue. And the stream is a sequence of again characters. So it's also kind of new API. It's also there in the Java 8. But we'll be more doing examples on the list in this. When it comes to the map, yes, we will be talking about all these three categories: hash map, list map, and tree map. And a set also we'll discuss: hash set, list set, tree set. Okay, and others we really not required. If anyone is interested, please go through your own, and if you find any difficulty, please let me know. I'll try to spend some time with you guys. Any questions? Any questions? Yeah. So far we have seen only the top level, parent level things. So tomorrow we'll continue with the low level actual data structures. Okay. Thank you guys. Thanks for your time. If you guys have any doubt, please ask me, else we can leave for the day.
Thanks, Rohit.
Thank you. Bye.
Thanks, Ravi.
Thank you all. Bye.